Hey, it's Mr. Kingsbury. I just wanted to shoot you a quick video here to help with kind of two ideas. One is the idea of midpoint, and the other is the idea of segment and angle addition. And as always, mathematicians tend to take what is a very simple idea and use some very large words to describe it, which makes it a little bit harder to understand. So let me see if I can break it down. Let's start with midpoint, all right? So in the midpoint of a line is the point that is the same distance from 2 points on a line. What I mean is, if you have a line, right? Here's point A, here's point B. Midpoint is exactly in the middle. I don't know why I made that an arrow. I meant to do that, right? That's the middle, right? That means this length is the same as this length. If this is 5, this is 5. If this is 12, this is 12. So it's in the middle. All this is saying is we're going to call the point that's in the middle the midpoint. It's that simple. If you think about it too hard, then you're overthinking it. What is interesting is you can use that idea to come up with some other things and to solve problems, which we'll get into in a moment. But first, let's just figure out, how do we know what the midpoint is of a line? Well, it depends on where that line is. Here's what I mean. If I gave you a horizontal line like so, and I told you that this is point A and this is point B, right? Like, and let's say this is a ruler, right? Let's say that A is at 1 on a number line and B is at, say, 9 on a number line, and I wanted to know what number is the midpoint at. But I didn't have the whole ruler out or the whole number line out. Well, all you'd have to do is figure out how long is this, right? Well, that would be 9 minus 1. That's 8. That's how long it is. This whole thing is 8. Well, we need half of that. So we would take 8 and we'd cut it in half. Right? So we would know that this is 4 units and this is 4 units. So we could either count 4 units bigger than 1, right? Let's do this. 5, nope, getting ahead of myself. 1 plus 4 is 5. Or we could come from this end and say it's going to be 4 less than this, right? 9 minus 4, also 5. So this is going to be 5, right? Like if this was just a number line, we could probably just count it if we wanted. Wouldn't be that big deal. We just need to know how big each of these pieces are. Similarly, if I gave you a vertical line and I said, oh, here's point A and here's point B, what's the midpoint, right? And let's say point B is at, I don't know, 3, and point A is at, I don't know, 15, right? You would do the same thing like we did up here. You go, well, how long is this whole line? Well, to figure that out, we go 15 minus 3, which is 12. So this whole thing is 12. And since this is the midpoint, we know this is half of 12 and this is half of 12. So we can take 12 and divide it by 2 and we get 6. So this is 6 and this is 6. And then from there we can either go, all right, 15 minus 6 is 9. Or here we can go 3 plus 6 is 9. Either way, we know that our midpoint is at 9. That's how you do that. You figure out, all right, the midpoint is halfway between these two. What's the whole distance? Figure out what half of that is and either add it to the smaller number or subtract it from the bigger number. What becomes interesting is when you no longer have a horizontal or vertical line, but instead a diagonal line. Because within a diagonal line, you're dealing with things in 2 dimensions now. Here's what I mean. Let's say we have point A here and point B here. There is some point that's in the middle. We'll call it point M. But this isn't just a straight number line anymore. Okay? And in fact, we'll probably have some sort of number line down here and some sort of number line going this way. Usually we call these the X and Y axes. Ooh, that was sneaky. I snuck that in there. Can you believe that? So let's call this, we'll make it simple. All right. Well, so we'll call this 1, 2, I did not do a very good job of this. I'm redrawing my line. We'll make B go out here. I didn't think this through, guys, okay? So let's say we've got 0, 1, 2, 3, 4, 5, right? And let's say this is 1, 2, 3, 4, 5, 6, 7. All right, so this point B is at, let's label these 1, 2, 3, 4, 5, 6, 7. Okay, so the point B here is at x value 7 and y value 5. That's its ordered pair that marks where it's at in the coordinate plane, 7, 5. The point A is at 1, 1. Now, because this is at a diagonal, we're going to have to look at both the vertical and the horizontal components. What I mean is we're going to do both this and this. Okay, so let's just look at this. The A is here at 1 and the B is here at 7, right? So don't worry about all this up here right now. We're just going to look at this. We're going to go from A to B, right? From 1 to 7. That's 1, 2, 3, 4, 5, 6 units. What's half of 6 would be 3. So you can either go 1, 2, 3, or you can go 1, 2, 3. Either way, that's where your midpoint is. That's the x value of the midpoint. Oh, look at that. There's M, by the way. Now let's do that same thing over here, right? We've got A is at 1 and B is at 5. So A is at 1, B is at 5. So we've got a length of 1, 2, 3, 4 units. What's half of 4? 2. So we can either go up 2 or we can start up here and go down 2. Either way, M is at 3. So the ordered pair of M would be 4, 3. That's ultimately what's going on here is you have two ordered pairs and you are finding halfway between the x's and halfway between the y's. All right? That's all there is to it. Now what happened is that scientists didn't want to take the time, or mathematicians I should say, didn't want to take the time to have to draw all this out. Plus you get ones where it's really nasty and you have decimals and that becomes kind of a pain in the bottom. So they said, how can we figure out a fast way to do this with algebra instead of drawing a picture? You can always draw a picture if you want, okay? There's nothing wrong with that. Algebraically, how would we do this? Well, it turns out if you average the x's and average the y's, you get what's in the middle, okay? Here's what I mean. 7 plus 1 is 8. 8 divided by 2 is 4. That was our x value, right? Let's do the same with the y's. 1 plus 5 is 6. 6 divided by 2, because I'm adding two numbers, is 3. So from that, they came up with this thing called the midpoint formula, right?
I found this on the way.
Oh my goodness. For some reason, Siri is listening to me on my watch. I don't know why. It's kind of annoying. Anyway, they came up with this formula. It's kind of cool. And it's a formal way to say what we just said. If you're given 2 points, x1, you know what? I'm going to do it like this. Let's say you're given the point AB and the point CD. And you want to find the midpoint, right? The midpoint will have an x value and a y value. To find the x value, you would take the x's of the points you were given, A and C. You would add them, and you would divide by 2. You average them. That's all it is you're averaging the x's. Same thing with the y's. You would take the two y values, B and D, and you would average them. Not a big deal. Okay, and don't overthink it. I find that a lot of times people get lost in the descriptions, the words, and they overanalyze. It's not huge, I swear. So let me just give you an example of how to do this quickly algebraically. All right, let's say that I give you the point 1, -2, and 3, 4, and we want to know what is the midpoint. We don't know. Well, take the 1 and the 3 and average them. 1 plus 3 is 4. So we now have 4 over 2. 4 over 2 is 2. So the x value of the midpoint is 2. Do the same thing with the y's. -2 plus 4 divided by 2. We're averaging it. Negative 2 plus 4 is positive 2. So we now have positive 2 over 2. 2 over 2 is 1. So the midpoint is 2, 1. That's it. That's all there is to it. I promise it doesn't get any more difficult than that. Let me give you another example. And then I'm going to make it more difficult because I'm a lying liar. Let's say I give you negative 6, 1 and negative 2, negative 3. And I want to know what's the midpoint. Again, average the x's, right? So negative 6 plus negative 2 over 2. Whoops. Helps if I write the right number, huh? Negative 6 plus negative 2 is negative 8. So that'll be negative 8 over 2. Negative 8 over 2 is negative 4. Average the y's. 1 plus negative 3 over 2. 1 plus negative 3 is negative 2. So we now have negative 2 over 2, which is negative 1. So the midpoint is negative 4, negative 1. Not a big deal. The fun comes when I say, or when you are given something like, here's one of the points, say 4, negative 5, and I tell you that the midpoint is negative 3, 9. You're not going to average these. This negative 3 is the result of averaging 4 with something. Right? Let's say this is point A. We want to know what's point B. We don't know. So when we average 4 with some x value from this other point, we get negative 3. We don't know what that is. Same thing with the 9. The 9 is the result of averaging negative 5 with something. So that's kind of not fun, right? You have to work backwards a little bit. It's not that bad, though, I promise, because remember, we got variables and we got algebra. So what would we do to get negative 3? We would take 4, we would add it to some number we don't know, and then we would divide by 2. And that would give us negative 3. So let's work it backwards. First thing we need to do is undo division by 2. Well, the opposite of division is multiplication. So I'm going to multiply both sides by negative 2. On the left side, these just cancel and leave me with 4 plus x. On the right side, negative 3 times negative 2 is positive 6. So now I have 4 plus x equals 6. How do I get x by itself? Well, I need to cancel this positive 4. The opposite of positive 4 is negative 4. On the left side, 4 minus 4 is 0. 0 plus x is x. On the right side, 6 minus 4 is 2. So it looks like the x value of b is 2. We're going to do the same thing with the y's. So to get 9, we took negative 5. We added it to some y value we don't know, and we divided them by 2. And that gave us 9. I'm going to do the same thing. I will multiply both sides by 2. Helps if I make it say what I'm saying, right? 9 times 2 is 18. On this side, the 2's cancel and leave me with negative 5 plus y. Then I need to cancel negative 5. The opposite of negative 5 is positive 5. On the left, negative 5 plus 5 is 0. 0 plus y is y. On the right, 18 plus 5 is 23. So it looks like the y value of point B is 23. So what I've just done is said, hey, interesting. I just thought of something I'll mention in a second. I said, hey, if I wanted to find the midpoint between 4, negative 5 and 2, 23, it would be negative 3, 9. It just occurred to me, by the way, that if you found the distance from 4 to negative 3, and then you moved that distance again, I mean, that would be another way to do it. Like if you could draw a picture, I guess. I don't want to confuse you, but you could just draw a picture. In the x direction, you're at 4, 3, 2, 1, 0, 1, 2, negative 3, right? So that's 1, 2, 3, 4, 5, 6, 7. If you keep going 7 units, 1, 2, 3, 4, 5, 6, 7, right? So negative 3, 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. I think I screwed that up. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Uh-oh. Oh. Well, that should have worked. Wonder what I did wrong here. Oh, look at that. I made it negative, didn't I? And it shouldn't have been negative. This should have been -6, which gives me -2. Wow, I made a mistake. I'm glad I checked my work. Whew. Because what I was saying is not wrong. If you figure out the distance from here to here and then do that again, you'll find out your x value. And then if you do that vertically, I don't know if you can see, do that vertically, right? We're starting at -5, I guess, and going to 9. So here's -5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 14 units. So you'd have to go 14 more, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Pretty sure you can't even see on my paper anymore. So we got 9, 10, right? 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Hey, I got that one right. Go me. It's just another way to look at it. I hope I didn't confuse you. But it's just a different way to look at it. If the math is like making you want to. The other concept that is included in week 4 here is the idea of addition or segment and angle addition. And the idea is very simple, but what we can do with it is kind of profound. What happens is when we start off with the simple stuff, everybody gets that. They're good. Like, oh yeah, no problem. But then when we start to make it more complex, then people start to lose sight of what's going on. Here's what I mean. The idea behind the addition postulates, there's 2 of them. Segment addition postulate and then the angle addition postulate. Right. The idea behind them is the segment one is for lines and the angle one is obviously for angles. The idea is really, really simple. It's just that if you have 2 angles next to each other, their measures add up to the measure of the big angle that they make, right? We're the same with segments, right? If you have 2 small pieces of line, they add up to the length of the whole line. That's the whole idea. And if you can keep that in mind, then you can set up equations to solve, all right? So what happens is we start off simple, right? And we work to the sublime. So for example, if I told you that I had a line, right? This is A, B, C. And I told you that AB was 7 units long and BC was 2 units long. And I wanted to know, so AB is 7, BC is 2. And I wanted to know what AC is. That's the whole thing. You would go, well, that's easy, Kingsbury. You take the 7, you add the 2, and you get the 9. It's 9. No big deal. And, you know, we can do stuff like that all day long, right? People are like, hey, that's not a problem. Then what happens is I switch it up a little bit, and we start to get a little less certain, which is fine. It's usually a new concept at that point, right? So, again, A, B, and C. Let's say that this is 4, and let's say that this is X, right? People see that and they're like, there's another letter here, because they're used to the letters being the labels, and then I threw X in here. That's a variable that represents the length, okay? So this is 4, this is X, and what if I told you the whole thing was, I don't know, 15? Right, it's 15. I know this part is 4. I don't know how big this is, but I know the whole thing is 15. I'll even write it out. AB equals 4, BC equals X, and AC equals 15. What you have to remember is that AB plus BC equals AC. That holds true. That's what we did up here, right? AB plus BC equals AC. And in this case, I was able to go, oh, 7 plus 2 equals 9. I can do the same thing here. We know that AB is 4. We know that BC is X. We know that AC is 15. And we know when we add AB and BC, what we get is AC. So we know, based on this relationship, that when we add 4 and x, we get 15. Now we have an equation. So from here we go, okay, forget the geometry. Now we're in algebra. How do I solve 4 plus x equals 15? Well, I need the x by itself. To do that, I need to cancel positive 4. So the opposite of positive 4 is negative 4. So I subtract that from both sides. 4 minus 4 is 0. 0 plus x is x. 15 minus 4 is 11. So x is equal to 11, which must mean that BC is equal to, because BC equals x. And that's when it starts to get a little more complex. And people are like, oh, I'm not sure. And then we go all in. Don't hate me. And I'm just kind of making this up on the fly, honestly. Hopefully this works. Let's say that this is 2x plus 1, and this is 4x minus 1. Ooh, I like that. And then let's say that the whole thing is, I don't know, some length, 18 maybe. Here's what happens. First of all, we just went from having simple numbers like up here, or maybe one variable, to suddenly we have these expressions that represent length. And they may even take it one step further and give you an expression here. I mean, I could have, I didn't, but I could have. The second thing that happens is you're no longer being asked one question, you're being asked 2 questions. You will be asked, what is the value of x? And what is the length of one of these segments? They may even ask you, what's the length of AB and what's the length of BC? And if this is some expression, they may ask you, what's the length of the whole thing? Maybe asked 4 questions. So it's not enough just to solve for x, then you have to plug it back in. Okay? I know, lots of fun. So how do we solve this? Well, the thing is, the one constant in all of these cases is that the 2 pieces add up to the whole. AB plus BC equals AC. We know that AB is 2x plus 1. We know that BC is 4x minus 1. And we know that AC is 18. When we add the 2 pieces, we get the whole. That hasn't changed. What changes is what we're substituting in to represent the lengths. We went from having just straight up lengths to having one length and one variable to now having an expression. It's more complex, but the basic idea hasn't changed. The 2 pieces add up to the whole. It's just what the pieces look like has changed. All right. It's like when you're doing puzzles, right? You start out with really simple puzzles with big pieces. And then as you do more difficult puzzles, you get more pieces and they become smaller. I actually saw one that one of the teachers at school did that was almost entirely corner pieces. You had to figure out how to put this thing together, and it's all corners. It's crazy. Anyway, my point is, the relationship hasn't changed. The 2 pieces add up to the whole. What has changed is what we put in place. Now, I put the parentheses here just to show you what I was substituting in for each piece. They don't serve any other purpose. So if we wanted, we could completely get rid of them. And it's a good thing we do that, because then we can start combining like terms, like 2x's and 4x's is 6x's. And 1 and negative 1 is actually 0. And 6x plus 0 is 6x. So I get 6 times x equals 18. The opposite of times is division, so I will divide both sides. I don't know why I'm dividing by 8. That's ridiculousness. I need to divide by 6. So I get x equals 3. Now that's the first part. And if I ask you, what does x equal? Then you're done. Usually, though, you'll then be asked, what's AB or what's BC? So you have to take this and plug it back in. So if I want to know what AB is, for example, we know that AB is 2 times x plus 1. Well, we know that x is 3 now. So instead of this being 2 times x, it's 2 times 3. 2 times 3 is 6, plus 1 is 7. If I wanted to know what BC was, originally it was 4 times x minus 1. But we know that x is 3. So this is actually 4 times 3 minus 1. 4 times 3 is 12. Minus 1 is 11. And here's how I know I'm right. The two parts add up to the whole. 7 plus 11 is 18. That's the whole idea, is the two smaller pieces, the two parts add up to the whole. Now that doesn't just apply to lines, it applies to angles as well. I'm not going to go through all of the examples that I did for the lines because that could take a little time, but the idea is the same. What are we on, example 4 or something like that? 4 or 5? I don't know. I lost track. Example 4 it is. If you have two angles, I'll just give you a simple one. If this is 38 degrees and this is 41 degrees, and I want to know what's the angle of the big thing, right? And remember, we use 3 letters for angles, right? So let's say this is A, B, C, and D, right? So if angle ABC is 38 degrees and CBD is 41 degrees, I want to know what the whole big thing is, right? Well, the parts add up to the whole. ABC plus CBD equals ABD. And I know when I started talking like that, when I started using all those names, some of your eyes started rolling in the back of your heads and you started like twitching in your seat. You're like, oh my God. The idea is solid though. Stick with the idea, not the names, all right? This piece, 38, plus this piece, 41, equals the whole thing, which would be 79. It's the same idea as the lines. You're just adding them up. So if I gave you something a little more complex, like if I gave you an angle thing again, all right, I won't even put letters in it. Let's just say that this is 45 and this is X. I don't know what X is, but I want to know what's the whole big thing, right? What is the big guy? Oh, I'm sorry. That's a lie. What if I told you the whole big guy was 98 degrees? Not my favorite boy band, by the way. NSYNC, way better than 98 degrees. I'm just saying. Anyway, I know that if I added 45 and X, that should give me the 98. And then I have this equation, an algebraic equation that I could then solve by subtracting 45 from both sides. So X would equal 53 there. That would be the measure there. And I could give you an example like the last one we did with the segments, with the lines, where you have an expression here, an expression here. It's the same thing, right? I'll set it up, but I won't solve it for you, right? Because I don't want your mind to be blown out of your head, all right? Let's say that this is 3x plus 2. And let's just call this 2x. That's fun. And let's say the whole thing is like 10x minus 7. And just for fun. Okay. So we know that the parts add up to the whole, right? So we know that ABD plus DBC equals ABC. That hasn't changed. Now, what has changed is what we're going to substitute in for those, and it looks pretty freaky. I mean, ABD is 3x plus 2, and DBC is 2x, and ABC is 10x minus 7. We know when we add these two, the parts, we get the whole. Now, from here, then we could drop the parentheses, combine like terms, and solve. And then here, from there, you have to be very careful. And I promise you there's one in your quiz like this where you can solve for x, but it doesn't ask what's x. It asks what is DBC or something like that. So be careful of that. What you have to do is hang on to this concept that the two parts add up to the whole. That's the whole idea, all right? If you get stuck, let me know. Email me, what have you, and I'll be glad to help you, okay? Good luck.